let's get into chapter 5. Chapter 5 is all about ratios and rates. So our first lesson here, we're going to focus in on what are ratios versus rates. And another key vocabulary word is a unit rate. So let's first go through this table at the top with our vocab. So a ratio is a comparison of two quantities using division. So remember, when we show a ratio, you might see it as a fraction because a fraction shows division. So the ratio is 3 to 4. Another way to write it, not only as a fraction, is with words. Another way you might see it is with those semicolons, or you might call them dots in between. But we say all of them, it's a 3 to 4 ratio. A rate is a ratio, but the two quantities have different units. So the ratio is 60 to 20 here, but it's 60 miles for every 2 hours. So there's specific units and they're different. And then there's a unit rate. That's a rate, but the denominator is 1. So it's basically when you simplify a rate. So it would be 30 miles per hour. And we took that just from here. If it's 60 miles in 2 hours, the unit rate would be 30 miles in 1 hour. But it's the denominator that we're looking to be 1. All right, let's continue on. Let's do some practice with ratios, rates, and unit rates. I want you to think about maybe where you might have seen or know how there's a rate that applies to you in your real life, in the real world. Rates and ratios are very common. You might see them anytime you are in the car driving with your family. There's a rate on the side of the road there. There's lots of rates all over. So see if you can think of one and go ahead and write that in this box here. Once you've thought of a real life example, we're going to move on here. So I'm going to look over to the left. There are 45 males and 60 females in a subway car. The subway car travels 2.5 miles in 5 minutes. So we're going to answer these few questions in the boxes below. It wants us to find the ratio of males to females. So we're going to do a males to females ratio. So there were 45 males to 60 females. So our ratio of males to females would be 45 to 60. You can write that as a fraction. You can write that with words or with the colons in between. Any of the 3 ways that we show to represent a ratio, like we did up top here in our examples, are appropriate here. You'll most commonly probably see them moving forward as fractions. Now, whenever you write a ratio, you want to make sure you're simplifying if you can. So go ahead and simplify this fraction. And in simplest form, so you might take multiple steps to get here, but in simplest form, you should get 3 over 5. Okay. So, or did I say 3 over 5? 3 over 4, because we're really dividing each one. You could divide them each by 15. That would be it in one step. You might have taken it and divided them both by 5, and then notice you can still divide them both again. After you divide them by 5, you can divide them again by 3. Okay, let's keep going here. We want to find the ratio of females to total passengers. So females, again, there were 60 females. Over how many total passengers were there? Well, if there's 60 females and 45 males together total, add them, you would get 105. Again, I know I can simplify that. So again, you can break it down into 2 steps. So maybe you're like, oh, I can divide these both by 5. Go ahead and divide them both by 5. 60 divided by 5, what would that give us? Hopefully you're thinking 12. And then 105 divided by 5 gives us 21. Now you should be asking yourself, can I simplify that anymore? You should be thinking yes. I can divide both by 3. So now 12 divided by 3 gives me 4. 21 divided by 3 gives me 7. So my ratio of females to total passengers is 4 to 7. And our next problem asks us to find the speed of the subway car. So it told us that the subway car travels 2.5 miles in 5 minutes. You should know that speed tells us how fast it is traveling, and that speed is going to be a rate. To find average speed, we put the total distance over the total time taken. So we're going to write this as 2.5 miles. I'm going to just abbreviate, over 5 minutes. That would be our speed. If you wanted to, you could find the unit rate. How long would it take it every minute? But it was 2.5 miles in 5 minutes. That's the speed. That's how fast that subway car is traveling. Okay. Let's continue on to our next, finding a rate from a ratio table. So a rate from a ratio table. The ratio table shows the cost for a different amount of artificial turf. Find the unit rate in dollars per square foot. So looking at this table, it's telling us, okay, 25 square feet cost $100. 100 square feet costs us $400, and so on. I want to know how much is it per 1 square foot. So when you're finding a unit rate from a table, you have to just use one of the rates. Choose a rate. I could choose the first one. I could choose any of these. I'm going to just choose the first one here. And I want to know dollars per square foot. So I'm going to rewrite this as dollars over square feet. So it's $100 for 25 square feet. I want to know how much is it for 1 square foot. That's what I'm trying to figure out. The unit rate. I want my denominator to be 1. So what do I do to 25 to get 1? Well, I would divide by 25. Whatever I do to the bottom, I should do to the top to figure out my answer here. So what's 100 divided by 25? That would give us 4. So our unit rate here is it costs $4 for every 1 square foot. Doesn't matter which one you would have chosen. Okay, it's a ratio table. All the rates are equal. So it would all simplify down to 4. You would get $4 per square foot no matter what as the unit rate. Now, what if we were to find a rate from a graph? So that was finding a rate from a ratio table. Now we're going to find it from a graph. So it says that the graph shows the speed of a subway car. Find the speed in miles per minute. So I want to know how many miles it traveled in 1 minute. Well, here are 2 points. You can choose either one, but we're going to write miles over minutes. So you need to be able to read these points. Your X represents the minutes. Your Y represents the miles. So in this ordered pair, you have to know that first comes your X and then comes your Y. So when I'm doing this, my X, again, is your minutes. I want to write it as miles over minutes. So let's fill that in from this ordered pair. I'm just going to choose the first one here. So my X is my minutes. So I'd put 1/2 on the bottom. In half a minute, this subway car travels 1/4 of a mile. Now they want us to figure out how many miles is it in 1 minute, per minute. They want the unit rate. So I need to get this denominator to 1 minute. What do I do here to get from 1/2 to a minute? I can multiply by 2. If you thought divide by 1/2, you're absolutely correct. Dividing by 1/2, that works, is the same as multiplying by 2. So either way works. But whatever you decide to do, I'm going to do the multiply by 2 way. I then have to do that up here as well. So really multiplying by 2 over 1. And now let's just simplify. So this car is going to travel 1/2 a mile in 1 minute. That is the unit rate. Last box here, compare the speeds of the 2 subway cars. So this one down here travels 1/2 a minute or 1/2 a mile every minute. The one at the top here traveled 2.5 miles in 5 minutes. So real quick, let's think, how far did it travel in just 1 minute then? In order to compare them, we want them to be the same. So let's figure out the unit rate here. I would have to divide by 5 to get this to 1. So divide 2.5 by 5. So do your long division. 2.5 goes on the inside, 5 on the outside. I can't divide 5 into 2, so let's bring our decimal up. How many times can 5 go into 25? 5 times. I get 0. So 0.5 or 1/2 of a mile. So this one, the unit rate is 1/2 a mile per minute. Down here it was 1/2 a mile per minute. So the speeds are equal because they're both 1/2 a mile per minute. All right, we are going to, in part 2's video, talk about ratio tables some more and what happens when we see problems like this word problem here. So tune in to part 2.